for each random variable probability function. Okay, this is what kind of random variable, ma'am? Discrete random variable. Okay, so this table, this arrangement is called as. So this is our joint probability distribution. The just generally probability distribution of a single random variable is like this. For each random variable value, we have probability function. Okay, so this is the probability distribution. So in this unit, we just deal with two random variables, not just one, two random variables. So simultaneously, we are just putting this probability distribution for both the random variables. Okay, so here our x random variable values of x and y. So this is our joint probability function. So P11, P of x1 comma y1, P12, P of x1 comma y2, like this, right? So here P of 1 comma star means it is the marginal probability distribution. Okay, and not y, only for x. And here P of dot 1, dot 2, dot 3, which means marginal probability distribution of y. Y only varies 1, 2, 3. Y only varies in place of x there is just a dot. And here marginal probability distribution of x. So in place of y we have only star. Okay, is this clear with this table?
In place of x there is a dot. In place of y there is a
In place of y, this is a star, since it is the marginal probability distribution of x, and this is marginal probability distribution of y. What is the marginal probability distribution first? Just for a single random variable, a single probability function is our marginal probability distribution. Okay. For example, for an event A, P of A is a marginal probability. Is it clear? For two events A and B, P of A union B, P of A union C, it is not marginal. It is joint probability. Since it contains two events, more than one events. If there is more than one random variable, more than one event, it is joint probability distribution. For a single random variable, not joint probability, marginal probability distribution. Is it clear? Okay. Write down the next definition after this table. Marginal probability distribution. Marginal probability distribution. The individual probability distribution of a random variable. The individual probability distribution of a random variable is referred to as its marginal probability distribution. The individual probability distribution of a random variable is referred to as its marginal probability distribution. Full stop. The set xi comma pi. The set xi comma pi is called the marginal probability distribution of x. The set xi comma pi is called the marginal probability distribution of x. Full stop. The set yj comma pj is called the marginal probability distribution of y. The marginal probability distribution of y. So what is this set represents, ma'am? For each random variable, its own probability, individual probability. That's why it is called marginal probability distribution of x. Similarly, for each random variable y, its own probability, corresponding probability pj, yj, tj. Okay, j varies from 1 to y1, y2, y3, y4. J varies. Okay, for y1 there is a probability p1. For y2 there is a probability p2. Like that. Okay, so it is a marginal probability distribution of y, x, y, and this is the pij, joint probability distribution of both x and y. Is it clear? It is single probability, individual probability for both the random variables, and it is the joint probability of the both the random variables. Can you understand the difference between these two? Everyone. Next definition. Independent random variables. Independent random variables. The random variables capital X and capital Y. The random variables capital X and capital Y are said to be independent random variables. Are said to be independent random variables if Pij equal to Pi star into P dot J. Two random variables x and y are said to be independent random variables if Pij equal to Pi star into P dot J. What is this mark Pij? Very good. Joint probability distribution. Okay. And what is this? Marginal probability distribution of x. And what is this?
Of y.
Marginal probability distribution of y. So, when the two random variables can be independent, you all know what is independent, right? Two random variables can be independent only if they are product of the marginal probabilities. Separate probabilities of both the random variables equals to their joint probability. For every value, for every random variable value, okay? Then only we can say the random variables as independent random variables. Otherwise, if at least one not equal to, at least some p12 not equal to p1 into p2, then the variables are not independent. Okay? Is it clear? Next definition, conditional probability distribution. Conditional probability distribution. Write this. Can anyone remember conditional probability formula?
P of A intersection B by B of A.
But what is the notation?
P of A given A given B.
P of A given B
Equal to P of A intersection B divided by P of B.
This is the conditional probability definition, right? So that is for two events. Okay. Now we are going to see the conditional probability for two random variables. So P of x equal to xi given y equal to yj. Anything is fine. Anything is fine. Okay. So this is our P of A given B. So this is our A and this is our B. A and B are events, but we are giving the numerical values. We are assigning the numerical values to each outcome of the event. So this is our random variable. Okay. X equal to 0, 1, 2. Y equal to 0, 1, 2. Like this. Is it clear? Okay. Instead of that event, we are just replacing it with the random variable. Okay. So the P of A intersection B divided by P of B. First event. This is first and this is second. This is the given one. This is the given one. Depending upon this, the probability of this one ensure. Okay. So P of A intersection B divided by P of B. So here random variable x, y and divided by P of y. This is what kind of probability, anyone?
Conditional probability.
This is the conditional probability only. In the numerator alone, what kind of probability? Joint probability, very good. Because both the x and y are here. So this is our joint probability distribution and this is marginal probability. Okay. Then equal to. So this is a joint probability, right? How can we write it? Pij. Pij. Joint probability we can represent it as Pij divided by marginal probability of y. How can we represent? Just see the table. Just see the table. P. Marginal probability P dot j. Marginal probability of y. So just marginal probability of y P dot j. Okay. Is it clear? If marginal probability of x P I star. Is it clear, ma? Just to differentiate between the joint probability and marginal probability. That's all. These notations just to give the differentiation between these two. What is joint probability? How can we represent? And what is the marginal probability? Like this. Is there any doubt? In the upper part, y random variables y1, y2, y equal, suppose y equal to 0, 1, 2, some values. Random variable are nothing but the real numbers, values. So in the upper part, y1, y2, y3, these are the random variables. Y random variables. Okay, y is a random variable, its values. We are just coordinating. And this side, first column x. Okay, and in between the P11, what is the P11? Joint probability of x1, y1. P12, joint probability of x2, y1. x1, y2. Like that. Now is it clear that Pij represents joint probability of the two random variables. Okay. So fine. And at last column, last row, P1 star, P2 star, which means marginal probability of the random variable x. 1 star. Star means there is no y at all, only x. So P1 star means marginal probability of x1. P2 star means marginal probability of x2. Okay. Similarly, in down, P dot 1, P dot 2. Dot represent there is no x. Dot 1, that second value, y. So P dot 1 is the marginal probability of y. P1, y1, very good. P dot 1 is the marginal probability of y1. And P dot 2 is the marginal probability of y2. So now is it clear? So here, it is just a general form, not 1, 2 like that number. Just ij, I varies, j also varies, some number. Okay. So this is the joint probability of xi and yj, and this is the marginal probability of y. Okay. Is it clear? of x. So equal to is called right after this one is called after this is called the conditional probability function. The conditional probability function of capital X. Conditional probability function of capital X given y equal to yj. Given y equal to yj. Here y is alone given, right? That's what I have. Next problems now. Now what is the bivariate distribution?
Two random variables.
Two random variables, okay. Joint probability distribution. What is the bivariate distribution, ma? Joint probability distribution, just another name. Okay, don't get confused. question தான். ப்ராபபிலிட்டி டிஸ்ட்ரிபியூஷன் கொடுத்துருவாங்க. ஓகேவா? அதாவது என்னென்ன ரேண்டம் வேரியபிள் வேல்யூஸ் என்னென்ன ஜாயிண்ட் ப்ராபபிலிட்டின்றது கொடுத்துருவாங்க. அதை யூஸ் பண்ணி நீங்க எல்லா क्वेश्चंसையும் சால்வ் பண்ணணும். ஓகேவா? என்னன்னா இந்த டேபிள் வந்து ஜாயிண்ட் ப்ராபபிலிட்டி டிஸ்ட்ரிபியூஷன் கொடுத்திருக்காங்க. ரெண்டு ரேண்டம் வேரியபிளுக்கு 1 ல இருந்து 6 y அப்ப எந்த டேபிள் வரைக்கும் இருக்கு? y வேல்யூ 1 ல இருந்து 6 வரைக்கும் இருக்கு. x வேல்யூஸ் 0 ல இருந்து 2 வரைக்கும். அப்ப இந்த ரேண்டம் வேரியபிள் வேல்யூஸ் 3 இருக்கு, இதுல 6 இருக்கு. சரியா? ஓகே. இப்போ இதுக்கு வந்து ஜாயிண்ட் ப்ராபபிலிட்டி டிஸ்ட்ரிபியூஷன். இப்போ இந்த 0வை நம்ம என்னன்னு சொல்லலாம்? கரெக்ட் தான். நான் தெளிவா சொல்றேன். P of 0, 1 P of 0, 1 தான் இந்த 0. அதுக்கு அப்புறம்
P of 0, 2
P of 0, 2 வந்து
0
0. இது P of 0, 3. ஓகே. இது
P of
0, 4. அப்ப தெரியுதுல உங்களுக்கு ஒவ்வொரு ப்ராபபிலிட்டி அந்த ரெண்டு ரேண்டம் வேரியபிள்ஸ்க்கு ஜாயிண்ட் ப்ராபபிலிட்டி வேல்யூஸ் கொடுத்துட்டாங்க. சரியா? அப்போ இப்போ ஃபர்ஸ்ட்ல இருந்து நம்ம கண்டுபிடிக்கணும். ஃபர்ஸ்ட் சப்டிவிஷன் என்ன சொல்லிருக்காங்க? P of x less than or equal to 1. இதுதான் क्वेश्चन. एक्चुअली அந்த ஃபர்ஸ்ட் சப்டிவிஷன்ல தான் क्वेश्चन ஸ்டார்ட் ஆகுது. ஓகேவா? அப்ப அந்த நம்ம ஒவ்வொன்றுத்தையுமே சப்டிவிஷன் வைஸ் நம்ம ஃபைண்ட் அவுட் பண்ணணும். இந்த வேல்யூஸ் யூஸ் பண்ணி தான் ஃபைண்ட் அவுட் பண்ணணும்.